Welcome to Calculus.
Our stress tolerance level has risen so high that nothing phases us.
On this episode, Stevenson will demonstrate
most real-life situations deal with just raw data. There isn't necessarily always some function that can model the behavior that the data is exhibiting. So here's an example of how we can use our calculus skills to help us gauge a situation without a modeled function. We have just a set of data. A pump connected to a generator operates at a varying rate depending on how much power is being drawn from the generator to operate other machinery. The rate in gallons per minute at which the pump operates is recorded periodically over 60 minutes, as shown in the table below. How many gallons were pumped during that hour? All right, how many gallons were pumped during that hour? So we need to approximate the accumulation of what happens here. Well, what have we used in the past for tables? We've used rectangular approximation methods, we've used trapezoidal approximation methods. It doesn't tell us what to use. Well, of all of the methods we've learned, trapezoidal is better than the rectangular, isn't it? So we're going to use a trapezoidal sum here. So we want to use it to accumulate the area under this. So we're going to go from 0 to 60. There's our minutes. And we're going to do the rate function times the time. So what that means is we're doing gallons per minute times minutes. So we're left with gallons, and that's what we want. It's asking how many gallons. So let's set up our trapezoidal sum. We have to use the data in the table, and if you notice, these are not regular intervals. So we're going to have to compute each trapezoid individually. So the first thing I want to do is figure out what are all of my heights. Let's fix this integral. Let's call our rate function r of t and time as t. So it's a little more official and it's more accurate of what we're dealing with here. Okay, so what I'm going to do now is I'm going to set up 1, 2, 3, 4, 5, 6, 7 trapezoidal sums here, or 7 trapezoidal areas here. Unfortunately, in this case, there isn't really any shortcuts because the heights here are all unique. There's not really any adjacent trapezoids that have the same height, so we can't use any shortcuts here. We cannot use trapezoidal rule because, again, the subintervals are not of equal length. So this is why it's a trapezoidal sum. We're just summing up the areas of a bunch of trapezoids. Now, I do notice that all of them have a half, so I'm going to factor out a half. Now, what I'm going to do is I'm going to go into my calculator and I'm going to type in all these sums and products and write them out here and just take my time.